Hi, my name is Kurosh Nuri, and I'm an AP Chemistry student from Bayport High School from Green Bay, Wisconsin. Today's AP Daily video is on topic 7.9, the introduction to Le Chatelier's principle. This video will investigate how changes in concentration, pressure, volume, catalysts, and temperature all can add stress to an equilibrium system. Le Chatelier's principle, or the equilibrium law, states that when a system experiences a disturbance, such as concentration, temperature, or pressure changes, it will respond and restore a new equilibrium state. If you change any of the conditions of a reaction, it will get thrown out of equilibrium, and this change in the system is called stressing. There are many ways to add stress to an equilibrium system. You can do so by changing the temperature, volume, pressure, or the molarity. In this graph, there is an increase in product, and where the dotted line is, you can see that there's stress added to the equilibrium. This sharp increase of the thiocyanate indicates the stress put on the reaction. The response to this stress is to increase the product of iron 3 thiocyanate and to decrease slowly both of the reactants, which reestablishes equilibrium. In this graph, there is a decrease in product, and the sharp decrease of iron indicates the stress put on the reaction, and the response to this stress is a decrease of the product iron 3 thiocyanate and an increase of both of the reactants, and slowly returning and reestablishing equilibrium. How does pressure affect an equilibrium system? Introducing moles of gas into the equilibrium can increase the pressure, but lowers the stress put on the expression. The increase in pressure shifts moles of gas to the side with fewer moles. Increasing the pressure of a system causes the reaction to produce more product and consume more reactant, which removes some of the stress off of the system. Adding moles of gas can also decrease the pressure, which also removes some of the stress from the system. This decrease in pressure moves the moles of gas to the side with the most moles. This also relieves stress on the system by creating more reactants and consuming more product. How does temperature affect the equilibrium system? When the temperature of a system increases, it is consumed by the endothermic side of the reaction, and it relieves stress from the equilibrium. In the endothermic reaction, the increase in heat is creating more product, so the old K value is smaller than the new K value. When the temperature of a system decreases, it is lost in the reaction, and the exothermic side of the reaction, which replaces the heat lost in the reaction to relieve stress on the equilibrium. In the exothermic reactions, the decrease in heat is creating more reactant, so the new K value is smaller than the old K value. How does water affect an equilibrium system? The addition of water to the system will dilute all of the aqueous species in the system, which reduces their concentration. This dilution attains equilibrium by shifting the water to the side which has the most aqueous species. When concentrating an aqueous equilibrium, the reaction will shift the water to the side with the least aqueous species to remain in equilibrium. What things do not add stress to an equilibrium equation? Catalysts have no effect on the equilibrium or the stress of an equation. The use of a catalyst increases the reaction rate for both the products and the reactants in both directions, therefore not adding any stress to the equilibrium. Adding extra solids to the expression also will not stress the equilibrium system. This is a practice AP problem. Which of the following changes alone would cause a decrease in the value of K for the reaction represented below? And I'll give you a moment to stop and answer this question. Give it a shot. And if you took your time and answered that question, you would see that the answer is B, because if you increase the temperature in this equation, the value of K would decrease because there are more products being created. Summary: when adding reactant, the product increases. When taking away reactant, the product decreases. Endothermic temperature increases create a larger K value, and exothermic temperature increases create a smaller K value. Increased pressure in the equilibrium moves gas molecules to the side with the least gas molecules. Decreased pressure in equilibrium moves gas moles to the side with the most gas moles. Catalysts and excess solids do not add stress to the equilibrium system. Thank you very much for watching.